What if literally every textbook, every equation, and everything you learned about the universe is completely wrong? Because right now, a $10 billion machine floating 1,000,000 miles out is sending back insanely terrifying data.
And this isn't just some glitch. Nobel Prize winners are officially calling it a massive crisis in cosmology.
Welcome to the day physics literally broke. So, for like a century, we thought we had the universe all figured out with the Standard Model. It was this flawless, elegant math that perfectly explained everything from the Big Bang to right now.
It honestly worked with an almost suspicious level of perfection. And then we turned on James Webb.
What Webb saw didn't just confirm our reality, it totally contradicted it and literally shattered the math.
This whole nightmare actually starts with just one single number, the Hubble constant. Let me explain.
This number basically measures exactly how fast the entire cosmos is ripping itself apart, right this second.
You'd think pinning down just one number would be insanely easy for modern science, right? But two different massive teams used two completely different methods and got two totally different answers.
Check this out. The first method looks way backward. The Planck satellite mapped the leftover Big Bang radiation.
Physicists plugged that ancient data into the Standard Model and ran the simulation forward 14 billion years. And their crazy math predicted the universe is expanding at exactly 67 kilometers per second.
But then comes the second method. Instead of modeling the past, they measure the present directly.
Nobel laureate Adam Rees and his team use a brilliant technique called the cosmic distance ladder.
They start by looking at these special, pulsating stars called Cepheid variables in nearby galaxies.
These stars literally throb with light, and the speed of their pulse tells us exactly how bright they truly are.
Compare that true brightness to how dim they look from Earth, and boom, you've got an exact distance.
From there, they step further out, looking for massive exploding stars called Type 1a supernovae. These explosions are so insanely bright, they all peak at almost the exact same luminosity.
So we can spot them in galaxies hundreds of millions of light years away and measure the distance perfectly.
Combine those distances with how fast the galaxies are flying away, and you get the new Hubble constant.
And guess what Reese's team got? Not 67, they got 73.
That is 6 kilometers per second faster than the Standard Model predicts. That gap is massive.
Now, you might be thinking, bro, isn't that just a tiny rounding error? Absolutely not.
In modern physics, we measure things to within 1%. An 8% gap is a total disaster.
It means the difference between a universe that's 13.8 billion years old and one that is way younger.
It literally changes the size of the observable universe and the timeline of when the first stars ignited.
You're not just adjusting a dial on a dashboard. You are redrawing the entire history of everything that has ever existed.
For a while, scientists naturally assumed someone had just made a mistake. It happens, right?
The most popular theory was stellar crowding. Cepheid stars tend to live in really dense, dusty parts of galaxies.
When the older Hubble telescope looked at them, its cameras sometimes blurred the light of nearby stars together. This blurring made the stars look way brighter than they truly were, which messed up the distance calculation.
If you could just clean up that blurry image, the tension would relax. So, they called in James Webb.
Webb's giant gold-plated mirror collects infrared light with a sensitivity that makes Hubble look like cheap reading glasses.
Everyone expected Webb to easily fix the error, drop the number back down, and save the standard model. Webb's infrared cameras literally cut right through the cosmic dust like a knife. It had perfect vision.
But guys, that is not what happened. Webb didn't fix the numbers. It confirmed them.
Almost exactly. The stars looked the same, the distances held perfectly, and the expansion rate stayed locked at 73.
In early 2024, the team published a massive paper. They measured stars 130 million light-years away.
The conclusion was absolute. Measurement error could officially be ruled out with very high confidence. Rees put it simply, with the errors eliminated, the only possibility left is that we misunderstood the universe.
Top physicists agreed. We shouldn't call it a tension anymore. We must call it a crisis.
By late 2024, the crisis got even deeper. Rees's team used 3 separate methods to measure distances.
All 3 methods completely agreed. They all pointed to a universe expanding way too fast.
So, either our entire model is wrong, or something invisible is hiding in the physics.
Some scientists think it's early dark energy, just a sudden, massive kick of expansion right after the Big Bang.
But nobody has ever detected it. And honestly, this tension would be bad enough on its own.
But James Webb delivered a second, absolute knockout blow to the standard model.
As soon as it started looking, it found galaxies in the early universe that had absolutely no business being there.
We are not talking about small, dim, infant galaxies. We are talking about massive monsters.
Galaxies that existed just 500 million years after the Big Bang, rivaling our entire Milky Way. Think about it. A galaxy that took our neighborhood 13 billion years to build somehow assembled itself in under a billion.
It pushed right up against the absolute limit of what physics allows.
To form galaxies that heavy, that fast, literally every available atom would have to convert into stars.
In a normal universe, that conversion rate is like 10%. These things were running at 100%.
Like a factory that somehow turns every single scrap of material into a finished product, with zero waste.
Physics just doesn't work that way. The initial reaction in the community was, frankly, sheer panic.
But then came a massive correction. A study in mid-2024 re-examined the data and found something crazy.
Many of these impossibly massive galaxies were actually nicknamed little red dots because of how they looked. Many of these impossibly massive galaxies were actually nicknamed little red dots because of how they looked.
The friction from all that falling material heated it up to extreme temperatures, radiating an insane amount of light.
From billions of light years away, through Webb's cameras, extreme brightness is usually a reliable proxy for mass.
So basically, the telescope saw the crazy brightness of the black hole and thought it was billions of stars.
It was essentially inflating the galaxy's apparent size, like literally taping a massive flashlight to a tiny candle. Once those little red dots were removed from the data, the remaining galaxies fit nicely back into the standard model.
The leading scientist bluntly said, "There is no crisis in terms of the standard model, at least from the galaxies."
But the story didn't end cleanly. Even after removing the red dots, roughly twice as many massive galaxies remained. It wasn't enough to completely break the standard model, but it was definitely enough to violently bend it.
Scientists suggested that maybe, just maybe, stars formed way faster in the early universe than they do today. The super-dense conditions right after the Big Bang made it harder for gas to escape, accelerating the whole process.
A totally reasonable explanation, right? But then, in early 2025, Webb found something else. A massive, perfectly structured spiral galaxy which they quickly nicknamed the Big Wheel.
It existed within the first 2 billion years of the universe. And honestly, that is a huge problem.
Because perfectly smooth, orderly spiral structures take a massive amount of time to develop.
You absolutely don't expect a calm, perfect spiral in the violently chaotic, crashing environment of a young universe.
Meanwhile, a separate team at Cambridge studied 250 galaxies from that exact same era and found the complete opposite.
Most of them were exactly what you'd expect. Messy, turbulent, clumpy systems that hadn't settled into smooth disks.
So we have messy adolescent galaxies, and at least one impossibly mature spiral. And if that wasn't weird enough, none of this addresses the problem of the elongated galaxies.
A study published in Nature Astronomy showed that many young galaxies observed by Webb appear
These prolit shapes don't match predictions at all. In fact, they completely defy the cold dark matter model. And that is terrifying, because cold dark matter isn't just one ingredient. It's literally the backbone of standard cosmology. It completely determines exactly where galaxies form, how they cluster together, and how the large-scale structure looks. It's literally the invisible scaffolding of the entire universe. If dark matter particles are somehow lighter, or behave differently than this cold model assumes, the ripples from that tiny change would violently propagate through almost every prediction we make.
It would instantly alter the calculated mass of massive galaxy clusters.
It would shift the entire expected distribution of tiny dwarf galaxies orbiting larger ones.
A distribution that, honestly, has already been causing extreme tension for years.
It would change exactly how gravitational lensing violently bends light around massive cosmic objects.
You literally can't just swap out the absolute foundation of a building
and expect the massive walls to magically stay exactly where they are.
So, where does this leave us right now? Is the standard model completely dead?
Actually, no, not even close. It still explains the cosmic microwave background with extraordinary precision.
It beautifully predicted the exact abundances of hydrogen and helium in the young universe.
It perfectly accounts for the clustering of massive galaxies across billions of light years.
Honestly, absolutely no competing model can even touch its massive track record.
Honestly, absolutely no competing model can even touch its massive track record.
But here's the catch. Despite all these massive wins, tiny cracks are starting to show up. And the biggest, most terrifying fracture of them all? Dark energy.
We used to think the universe's expansion was slowing down because of gravity. But in 1998, we found out it's actually speeding up. Something is pushing everything apart. And the standard model? It sits there completely silent. It has absolutely zero explanation for this.
We call it dark energy, but honestly, that's just a placeholder name for we have no idea.
When physicists tried to calculate the energy of empty space using quantum mechanics,
they got a number that was 120 orders of magnitude off. The worst prediction in the history of physics.
Think about it. The math says empty space should be violently energetic, but our universe is mostly smooth and stable.
So what exactly is doing the pushing? Some think it's a fundamental property of space itself.
Others think it's a dynamic, changing fluid filling the universe, something called quintessence.
Or maybe, just maybe, Einstein's theory of gravity starts breaking down on these massive cosmic scales.
And dark energy isn't the only crack. The universe is stretching in ways our measurements can't agree on.
Enter the Hubble tension. When we measure how fast the universe is expanding nearby,
we get one number. But when we look at the oldest light in the universe, the CMB,
we get a completely different number. And they absolutely refuse to match up. It's a literal crisis in cosmology. Either our tools are wrong, or there's a massive piece of physics missing.
So here we stand. Everything we know, stars, planets,
makes up just 5% of the universe. The rest is dark matter and dark energy. We are the anomaly.
The Standard Model is a masterpiece, but it's a masterpiece painted on only a tiny corner of a massive, dark canvas.
To understand this massive 95% missing puzzle, we have to split it into two dark twins. First is dark energy, the violent, unseen force aggressively pushing the universe apart. That's roughly 68%. Then there's dark matter, making up about 27%. It's the invisible, heavy glue holding everything together.
Dark matter is entirely different. It doesn't emit, reflect, or even absorb light. It's a literal ghost.
So, if we absolutely cannot see it or touch it, how do we know it's lurking there? She was observing spiral galaxies, measuring exactly how fast the stars at the very outer edges were spinning.
According to Standard Model physics, stars further away from the galactic center should orbit much, much slower. But Vera found the impossible. Those outer stars were whipping around at terrifying, breakneck, logic-defying speeds. They were moving with such violent momentum that they should have literally been flung into deep space. Imagine a playground merry-go-round spinning completely out of control. Without holding on tight, you're flying right off. But these galaxies weren't flying apart. Some massive, invisible force with immense gravity was holding them tight. This invisible, heavy, cosmic seatbelt providing all that extra gravity? It forms a gigantic, spherical, invisible halo around every single galaxy, keeping all those fast stars locked in. And it's not just spinning galaxies. We can physically see dark matter bending the light of the cosmos. It's called gravitational lensing. Massive clusters of dark matter warp the very fabric of space-time so heavily
that the light from galaxies sitting far behind them gets stretched, magnified, and distorted like a funhouse mirror.
We can literally draw a map of where this invisible ghost matter lives just by watching light bend.
So, we know it's incredibly heavy, and we know it's everywhere. But what on earth is it actually made of?
Is it a swarm of tiny, undiscovered ghost particles floating right through us? Or is it something much stranger?
For decades, the top suspects have been WIMPs, weakly interacting massive particles.
The theory says billions of these heavy, invisible particles are passing through your body right now.
To catch them, scientists went deep underground, miles below mountains, to block out normal cosmic radiation.
They built massive tanks filled with ultra-pure, freezing liquid xenon, waiting for a single WIMP collision. If a dark matter particle hits a xenon atom, it should produce a tiny, detectable flash of light.
But after years of watching, waiting, and upgrading these massive detectors,
absolute, deafening silence. So, physicists pivoted to another suspect. Meet the axion, a particle so incredibly light it acts like a wave.
If dark matter is made of axions, we are basically swimming in an invisible, cosmic ocean of them. To find them, we use incredibly powerful magnetic fields to force these axion waves to reveal themselves as light. But just like with WIMPs, The Axion detectors have found exactly nothing. The ghost remains completely invisible. Could be primordial black holes. Microscopic black holes forged in the intense heat of the Big Bang. They'd be heavy enough to provide the gravity, and dark enough to stay completely hidden from our telescopes. Footprints in the snow, but no monster.
This massive frustration led some rebellious physicists to ask, what if dark matter doesn't actually exist at all? What if it's not missing matter, but our fundamental understanding of gravity that is completely wrong?
So MOND is dead. Dark matter is a particle. Now, we need a brand new theory to find it.
The standard model is brilliant, but it's officially incomplete. We are chasing a theory of everything. Our best guess? Supersymmetry. It suggests every known particle has a heavy, invisible shadow partner.
We built the Large Hadron Collider to smash atoms together and create these elusive shadow particles.
But the LHC found
Absolutely nothing. Decades of searching, and supersymmetry is officially on life support.
time to think wilder. Maybe dark matter isn't just one particle.
Dark photons, dark atoms, dark life, a completely hidden reality.
To catch these dark photons, we need insanely precise experiments searching for light subtly turning dark. If the LHC failed, we need a bigger machine. Welcome to the Future Circular Collider idea.
Or maybe we need to look above the atmosphere, using detectors in space to spot dark matter signals.
For decades, space detectors have picked up weird positron excesses, possible hints of dark matter collisions.
But these hints are messy. They could just be from nearby pulsars. The signal remains infuriatingly ambiguous.
The data is too vast for human minds. Our final hope for a breakthrough? Artificial intelligence. By training AI to analyze entire galaxy maps, we are finding incredibly subtle anomalies we missed before.
Independent teams using different AI models are confirming this anomaly. This is a real hint of new physics. This is the moment. A legitimate, verified crack in the standard model. The hunt is reaching its climax. If confirmed, this rewrites everything about reality. Stars, planets, you. But the hunt isn't over. We've found the particle hint, but the mystery is still vast.
You are part of this journey now. If your mind is as blown as mine, smash that subscribe button.
In the next part, we tackle the 68% monster, dark energy. The true killer of the universe.
Forget everything you know. The universe isn't just expanding, it's actually speeding up. And it's terrifying.
In 1998, scientists looked at distant exploding stars, called supernovae, to measure how much.
But they found the exact opposite. Gravity wasn't winning. Something invisible was pushing the universe apart faster and faster.
Repulsive anti-gravity force. Dark energy. So, what the hell is it? The craziest part is, Einstein actually predicted it. Einstein proposed a cosmological constant. The idea that empty space itself isn't actually empty. It has its own intrinsic energy.
As the universe expands, more empty space is created. More space means more vacuum energy, which pushes the expansion even faster.
It sounds perfect, right? But here is where quantum physics completely breaks the math. And I mean, completely.
When quantum physicists calculate how much energy should be in the vacuum, the answer is 10 to the power of 120 times too big.
It is universally known as the absolute worst prediction in the history of physics. A complete theoretical disaster.
So, if it's not vacuum energy, what else could it be?
Unlike a constant vacuum, quintessence is a dynamic, living energy field flowing through the universe, changing over billions of years.
Whether it's a constant or quintessence, dark energy dictates the ultimate, terrifying fate of our...
Galaxies will get so far apart that light can't cross the gap. But there's an even worse scenario. If dark energy gets stronger over time, it leads to the Big Rip.
The expansion will become so violent it will tear apart galaxies, then planets, and finally, it will...
To figure out which doomsday is coming, we built the Dark Energy Survey, taking gigapixel photos of hundreds of millions of galaxies. By mapping how these galaxies clump together over billions of years, we can trace the exact battle between gravity and dark energy. But there's an even worse scenario. If dark energy gets stronger over time, it leads to the Big Rip.
The expansion will become so violent, it will tear apart galaxies. Then,
To figure out which doomsday is coming, we built the Dark Energy Survey, taking gigapixel photos of hundreds of millions of galaxies. By mapping how these galaxies clump together over billions of years, we can trace the exact battle between gravity and dark energy.
And James Webb Space Telescope is looking than ever. We are standing on the edge of the greatest paradigm shift in human history. Right now, we only understand 5% of reality. But that 5% was enough to build civilization. Imagine what humanity will do when we finally unlock the other 95%. The dark universe is...
What do you guys think? Is dark matter a particle, a whole dark sector, or is Einstein's gravity wrong? Drop your wildest theories down in the comments.
If you survived this mind-bending journey, hit that like button to feed the algorithm, and subscribe to Apex Cosmos for more deep space dives.
Next time, we're leaving the dark and diving straight into the most violent objects in existence. Quasars.